Hi everyone, my name is Garima Malik and I'm one of the PhD student in Ryerson University. And today I'm going to talk about the project which we are doing in collaboration with IBM and Ryerson University Data Science Lab. So the main goal of this project is to detect the semantic similarities and conflicts in software requirements. As we all know that SRS, which stands for Software Requirement Specification Documents, are pretty important documentation in software development lifecycle. They actually give you the foundation of clear and unambiguous requirements, which is delivered to the developers to build the applications. Now, sometimes it happens that there are a bunch of similar requirements and maybe conflicting requirements present in the SRS document. So, our goal is to detect all those semantic similarities and conflicts in software requirements. Regarding the literature review, so this problem is studied by very few people, and then there are very few existing methodologies available, starting from one of the very famous methodology, which is NLP rule based ones, where they are trying to extract the requirements from SRS documents using NLP rule based techniques. And the methodology is pretty much tedious and rule based. But the good thing about that is they have clearly identified and defined the rules on which you can decide whether a requirement is conflicting or similar in this similar or not. Then the other methodologies basically, so in this, Osman is just trying to investigate whether the requirements has a conflict or similarity or not. So he's just taking 180 requirements and then labeling it out and training a machine learning algorithm over it and just trying to determine like, okay, whether SRS documents are conflicting or not. Now, moving on to our methodology. So, as you know, the goal was to basically detect the similar and dissimilar or maybe conflicting requirements. So, we tried two types of techniques. One is we can try to extract the software specific name entities from the SRS documents, and then we can choose out of these three, which is mentioned in the methodology. We can either manually analyze the requirements, or we can either find the entity relationships between the software specific entities, or we can try some rule based approaches to find out the conflicting ones. The other one, methodology, which is very automated in the sense that we are using BERT TF IDF embeddings and feeding the BERT TF IDF embeddings of SRS requirements into the k-means clustering algorithm, where we are able to cluster all the similar kind of requirements in same cluster. And in those clusters, if we try to identify which one requirement is conflicting with the other, it's pretty easy because of the cosine similarity matrix we are using. So this is the methodology we are trying to portray in the poster as well. And to do this task, we have used IBM Doors stories and requirements, which is, highly dedicated to this platform. So we have used this data provided by the IBM collaborators in the project. And our main goal is to basically detect the semantic similarities and conflicts in software requirements. From this project, we have two contributions till now in the research literature. One is named entity recognition on software requirement specifications, and the other one is a BERT based transfer learning technique to do the text classification indoors data. And the other kind of references are provided here as well. So, in the nutshell, I just want to say that the problem is pretty tricky and it is very it is tackled by very few people, and there are few methodologies available. So we are just trying to develop a new methodology where we can automate this process of detecting the semantic similarities and conflicts in software requirements. So thank you so much for the listening and have a good day.